Easy and intermediate level geometry questions usually test single figures, one triangle, one quadrilateral, or one circle. More challenging geometry questions combine figures. Such combination figures may include overlapping quadrilaterals or triangles paired with squares. To answer these types of questions, we often must transfer information about one shape to the other. But some multiple figures, inscribed figures for instance, have special properties to consider. A figure is inscribed within a circle if all of its vertices lie on the circumference of the circle. In this diagram, rectangle ABCD is inscribed within circle M, square EFGH is inscribed within circle N, and triangle JKL is inscribed within circle O. In each figure, the radius of the circle is the length from the center of the circle to any vertex of the inscribed figure. In circle M, AM is equal to BM, which is equal to CM, which is equal to DM. In circle N, segments EN is equal to FN is equal to GN is equal to HN. In circle O, OJ is equal to OK is equal to OL. Let's try an in-format problem now. In this figure, if square ABCD has an area of 32, what is the area of circle N? Well, we know that this figure inscribed in the circle is a square. Since the area of the square is going to be the length of one of the sides squared, 32 equals S squared, where S is one of the sides of the square. And therefore, S equals the square root of 32, which simplifies to 4 radical 2. What we're interested in solving is the area of circle N. And we know the area of circle N is going to be pi times the radius squared. For problems such as these, it's important to note in your answer choices that pi shows up. So we don't have to worry about pi. What we're really interested in is what is r squared. We don't have to worry about multiplying pi through. We just leave it in our final answer. So we know that line segment BD is going to be the diameter of our circle. When we draw the diagonal of this square, we actually make two isosceles right triangles. And BD is not only the diameter of the circle, it's the diagonal of the square. So we know the sides of a 45, 45, 90 triangle are going to be x, x, x radical 2. And in this case, x is equal to 4 radical 2, so x radical 2 is just 4 radical 2 times radical 2, which is equal to 8. So we know the diameter is equal to 8, which means that the radius is just half that, 4. And now we're ready to plug this into our formula. The area of this circle has to be 4 squared pi, which is equal to 16 pi. And our final answer is B. The key here was knowing that the diagonal of the square is going to create two isosceles right triangles, and on top of that, the diagonal of the square is the diameter of the circle. So excellent work. Let's move on to inscribed triangles. If a triangle is inscribed in a circle so that one of its sides is the diameter of the circle, then the triangle is a right triangle, and the diameter is the hypotenuse. Otherwise, the triangle is not a right triangle. Triangle ABC is a right triangle because side AB passes through R, the center of the circle. AC and CB are the legs, and AB is the hypotenuse. Triangle DEF is not a right triangle because no side passes through the center S. So let's test our knowledge of inscribed triangles. In this figure, circle O has a radius of 5. What is the perimeter of the shaded region? So we're solving for our perimeter, and again we see in our answer choices that pi shows up, so we don't have to worry about pi canceling out at all or having to do any arithmetic involving pi. We're solving for the perimeter of this shaded region. So what the perimeter of the shaded region is literally going to be is, first it's half of the circumference, and then it's going to be the two sides right here, one of which is 8. So let's start by dealing with the circumference of this circle. We know that the radius is 5. And if the radius is 5, the circumference of the entire circle is 2 pi r, which is equal to 2 times pi times 5, or 10 pi. At this point, we say, well, this isn't the whole circle, it's just half the circle. For the perimeter of the shaded region, we know half the circumference is 5 pi. Now we need to add our final two sides. We know one of those sides is 8. Now we're just really interested in this last side. Well, since we know that the radius is 5, we know that the diameter is 10. Now we know we have a triangle inscribed in a circle that has the diameter as one side of the triangle. which means that that diameter has to be the hypotenuse, and we're dealing with a 90-degree triangle. So we can use the Pythagorean theorem to solve for our final side, but we notice we have our Pythagorean triplet. This is a multiple of the 3, 4, 5 triangle. It's the 6, 8, 10 triangle. And just because of that, we can save time without doing the calculations. And the perimeter of the shaded region is going to be 6 plus 8 plus 5 pi, or 14 plus 5 pi. Answer choice B.